This is Mapok from 3work, and let's get started. This topic is might tend to stretch a bit, so you can make use of the subtopics at the bottom of the screen. So this topic, we're going to look at the methods of representing relief on topographical maps, identification and description of the following in the topographical maps. So we're going to describe landforms, vegetation, drainage, economic activities and settlements, enlargement. We are going to look at the reduction of maps, draw a cross-section, calculate and interpret the vertical exaggeration and gradient, and finally determine the intervisibility. So in the first part, we're going to look at the methods of representing relief on topographical maps. 1A, you're supposed to describe, you should be able to describe the general appearance of the entire area, whether it's hilly, mountainous, a plain, undulating landscape, has many hills, isolated hills, and so on. Then you state the highest and the lowest parts of the area. You should be able to look out for valleys which are occupied by rivers. Divide into relief regions such as plateau, escarpment, and lowland. Explain the type of slope, whether it's gentle, steep, even, or irregular. Identify the direction of slope. And finally, identify the landforms present in the area. So we're going to look at, to start and look at it under the landforms. Look out for gentle slopes, steep slopes, even slopes, uneven slopes, convex slopes, concave, a valley, a spur, interlocking spurs, truncated spurs, conical hills, regular shaped hills, ridges, a col and a pass, a watershed escarpment, a plateau. We've covered all this, and it should be easy to go through them. We are going to look at the landforms, then vegetation, drainage, economic activities, and finally settlements. So, gentle slope. Slope is the gradient of land surface, and a gentle slope is one in which land doesn't rise or fall steeply. So the contours are wide apart. So let me show you the contours. These are the contours. They are wide apart. A steep slope, this is where land rises or falls sharply. So the contours are close to each other, as in this image. Let's look at even slopes and uneven slopes. Even slopes shown by contours which are evenly spaced, as represented here, while the uneven slopes are indicated by unevenly spaced contours, as represented here. So let's proceed. Convex slopes, concave slopes. So concave slope, one curved outwards, it's indicated by contours which are close together at the bottom and widely spaced together at the top, as presented here. While concave slopes, one curved inwards, so contours are close together at the top and widely spaced at the bottom, as shown here. So let's proceed. We're going to look at a valley and a spur. So a valley is a low area between higher grounds. It is indicated by U-shaped contours pointing towards a higher ground. So this is how it should be on your map. A spur, this is land which is projected from high to low ground, indicated by U-shaped contours bulging towards lower ground, as seen here. We're going to look at interlocking spurs, truncated spurs. So spurs which appear as if to fit together, as shown here, while truncated spurs are spurs in glaciated islands whose tips have been eroded and straightened, as represented like this on the map. We're going to look at conical hills and irregular shaped hills. Conical hills are uplands which rise above relatively lower ground. So conical hills are small rounded hills. And this is how they are represented on a map. While irregular shaped hills, a hill with some sides which with uneven gentle and others with uneven slopes. So regular hill as presented there. Let's proceed. We're going to look at ridges, a col, a pass, and probably a watershed. A range of ridges are a range of hills with steep slopes on all sides. So a ridge can contain hills, cols, passes, or watersheds. So a col is a low area which occurs between two hills. A pass, a narrow, steep-sided gap in a highland. And a watershed is a boundary separating drainage systems which drains into different directions. So we're going to look at an escarpment and a plateau as we close on the landforms as described on topographical maps. An escarpment is a relatively continuous line of steep slope facing the same direction. So has two slopes, a long gentle slope and a short deep slope as presented there. So a plateau is a high flat land bound by steep slopes as presented here. So that's the end of the landforms. And next we're going to look at how we can identify and describe vegetation on topographical maps. We're going to take a break and remind you that all these notes, they are available on your Google Play Store in this app, the Geography app by Revision K. And so something good about the app is you don't need data to read from. These are things tells it apart from many products on the market. So let's proceed. Natural vegetation is classified as woodlands, thickets, shrubs, or grassland. So symbols are given as pictures of vegetation. So we have forests. They are likely indicated in the area where there is heavy rainfall, fertile rainfall. It's weird. Cool temperature depending on the altitude. Thickets and shrubs. These are areas where there is seasonal rainfall. Poor soil, high temperature. Riverine trees, high moisture content in the river valley. Drainage. Natural drainage features include lakes, rivers, swamps, seas, rapids, waterfalls, cataracts, springs, deltas, fjords, sands, mud, and bays. Artificial features include ponds, wells, boreholes, waterholes, cattle dips, cattle troughs, canals, reservoirs, irrigation channels, aqueducts, water treatment plants, and man-made lakes. So you should be able to identify main rivers by their names on the map. The size of the rivers, big or small, is shown by the thickness of the blue lines, which represent drainage or water bodies. Be able to give the general direction of flow. This you can do by looking at the contours surrounding the rivers. So location of watershed if any, and the characteristics of each feature. So there are permanent rivers, there are seasonal rivers, you also have disappearing rivers. The drainage types we have the following: dendritic, rectangular, centripetal, trellis, parallel, radial, annular, and fault guided. So we're going to discuss that shortly. And so permanent rivers, these flow throughout the year. They are shown by continuous blue lines. They are likely indication of heavy rainfall and impermeable rocks. Seasonal rivers. These are which flow seasonally or during the rainy season. They are shown by broken blue lines and are likely indication of low rainfall. River doesn't have a rich catchment area. Disappearing rivers. They are represented by blue lines ending abruptly, and they are likely indication of permeable rocks, very low rainfall, and underground drainage. So we are now going to look at the drainage patterns and how they are represented on the map. Dendritic, they resemble a tree trunk and branches or veins of a leaf. So these are the tributaries that join the main river at acute angles. Trellis, tributaries join the main river at other tributaries, and other tributaries at right angles of hard and soft rock. So common in folded areas where rivers flow downwards separated by vertical uplands. So you can zoom this out so that you can see the key. So the one labeled 1, this is the main river. 2, this is the main tributary. 3, the minor tributary. We are going to look at, we've looked at dendritic and trellis, so we can look at rectangular and parallel. Rectangular pattern looks like a large block of rectangles presented here. Dots that we can see. Then tributaries tend to take sharp angular bends along their course. Parallel pattern, rivers and tributaries flow virtually parallel to each other. They're influenced by slope, common on slopes of high mountain ranges. That we're going to look at the centripetal and the annular drainage patterns. So centripetal pattern, rivers flow from many directions into a central depression such as a lake, a sea, or swamp. Examples of rivers is flowing to some of the Rift Valley lakes such as Nakuru, Bogoria, as represented here. So annular pattern, this is centripetal. Annular pattern, streams are arranged in series or curves about a basin or crater. It is controlled by the slope. And finally, radial and fault guided. So radial resemble the spikes of a bicycle, formed by rivers which flow downwards from a central point in all directions, such as on a volcanic cone. Fault guided pattern, flow of river is guided by direction of fault lines, as presented there. Finally, we're going to look at, not finally, we're going to look at economic activities. You should be able to identify types, evidence, that is man-made features, and the reasons why. Human activities or economic activities, be able to identify agriculture, livestock farming, mining, lumbering, fishing, manufacturing or processing, service, social services. So let's look at agriculture, livestock farming. Evidence by presence of sea. You'll note that from the key provided for the map. Named estates such as Kaimosi Tea Estate, that is plantation farming. Small scale crop farming, cotton spinneries or sheds, coffee, posho mills, tea factories or store. So livestock farming be presented by dairy farms, veterinary stations, cattle dips, creameries, waterholes, dams, butcheries, slaughterhouses. Mining, how is mining identified on topographical maps? We have a symbol of a mine or mineral works, maybe a name of the mine, particular mineral, example soda ash, or a quarry symbol. You'll be able to look at the key for the same, or a processing plant of a mineral. Forestry, lumbering, be able to see sawmills on your map and key, forest reserves, forest stations, forest guard post, roads ending abruptly into a forest estate used to transport logs to sawmills. Human economic activities, we're still them, so we're going to look at fishing and the manufacturing industry. So fishing, be able to see fish traps, fishing cooperative societies, fish ponds, fish hatcheries. Manufacturing, be able to see sawmills for lumber products, a mill for maize, millet, wheat processing, creameries for milk processing, factory for manufacturing or processing a known commodity. Services, we are going to look at them under trade, communication, tourism, and administration. Transport is easy. So to identify trade on a topographical map, should be able to see shops, markets, stores. Communication, should be able to see post offices, a telegraph, telephone line. Administration should be able to see DO, DC, police post, chief's camp. If the maps nowadays are updated, you should be able to see county assembly and so on. So tourism, you should be able to see camping sites, historical monuments, national parks, game reserves, museums. On transport, we're going to take some time here to look at the details. So transport one, land transport should be presented by roads, which are further shown as or whether can describe them as all weather roads, which are used all year round, such as where you see tarmac maram roads. Dry weather roads, which are used reliably during dry seasons. Air transport, you should be able to see airports, airstrips, airfields. Water, should be able to see ferries and bridges. So finally, we look at social services and human or economic activities. Religious services are identified with churches, mosques, temples. Education, you should be able to see named schools, colleges, universities. Health services, able to identify hospitals, dispensaries, and finally recreational services. You can see golf clubs, stadiums, and we are now headed to settlements. So a settlement is a place with housing units where people live together. Rural settlements, they consist of villages and homesteads in which people are involved in subsistence agriculture and traditional activities such as pottery, weaving, carving. Urban settlements consist of dense, permanent, and sometimes high buildings and population engaged in an agricultural activity such as industrial activities. So what are the factors that influence settlement? Physical factors, we have climate, relief, we have drainage, we have vegetation, we have pests and diseases, and we have natural resources. So settlements, for example, start where there is a mineral extraction. Human factors, we have political factors, historical factors, cultural factors, and economic factors. So we are still looking at identification and description of settlement patterns on topographical maps. And so a nucleated settlement pattern or clustered one will have buildings that are close to each other, like that. And this could be due to availability of social amenities such as schools and healthcare, shortage of building land, favorable climate, fertile soils, presence of natural resources, security concerns. We also have a linear settlement pattern where buildings are aligned in a line. And the factors that affect that would be presence of a transport line, for example, a road or a railway, presence of a river or a spring to provide water for domestic and commercial uses, presence of a coastline which has a favorable fishing ground. We have dispersed or scattered settlements, which could be presented in this manner. Factors that could lead to buildings being scattered to have plenty of land to build whenever they want. Avoidance of harsh climates, be in arid and semi-arid areas. Poor infertile soils, pests and diseases. Other physical features such as ridges, valleys which separate from houses. We have a radio pattern where buildings are arranged like a star, common at crossroads where housing units point in all direction as presented there. So that's done. We are done with identification and description or in topographical maps. We are now going to look at enlargement and reduction maps, and maybe it's time we can have some short break. Welcome back. So while enlarging and reducing maps, you identify the area that requires enlargement, measure its length and width, multiply or divide depending whether you are enlarging or reducing by the number of times given. So for example, the scale would be when you divide by 2, such a scale you are enlarging, and multiply by 2 you are reducing. So draw the name frame with new dimensions, insert the grid squares, draw diagonals on the frame, transfer features exactly where they are. How do we draw cross sections? So a cross section is a line drawn on a piece of paper showing the nature of relief of a particular area. You can take time to look at the steps to draw cross section. We are going to calculate and interpret vertical exaggeration and gradient. So a vertical exaggeration is the number of times that the vertical scale is larger than the horizontal scale. That's the formula to calculate vertical exaggeration. And that's how we interpret the same. So let's look at gradient, which is a degree of steepness of a slope between two given points. So you identify the 2 points, calculate the difference in height between the 2 points, join them with a light line, then you measure the ground distance between the 2 points, separate it. How do we determine intervisibility? So intervisibility is ability of one place to be seen from another. So you first draw the cross section, join the points, and if the visibility line is above the cross section, then the 2 points are intervisible. If below, then they are not intervisible. We'll link another class that handles exaggeration and drawing of cross sections. To have this, you need to have a graph would be good. So that's the end of our class, and we hope to see you in our next class, which is external landforming processes.